Assalamualaikum warahmatullahi wabarakatuh. I'm Ayudania binti Ahmad Shahrizan, currently studying Bachelor in Economics and Finance under FBMP faculty.
Hello to Madam and everyone. My name is Nur Rafi Hidayah binti Nur Ashid, and I'm currently taking a Bachelor in Logistics under the faculty of FBMB. My metric ID is 0120-240-20783, and I'll be doing the arithmetic sequence.
Hi everyone, my name is Nur Sabrina. I am taking Bachelor in Logistics Management and my student ID is 0120-240-20470, and I will be doing the geometric progression.
Before we start with the exercise, I will talk about what is this topic 4 is about. So topic 4 is about arithmetic and geometric sequences. So what is the definition of sequences? A sequences is a set of numbers arranged in a specific order where each number is derived based on a particular rule or pattern. So there are two types of sequences, which is arithmetic and geometric. So what is arithmetic sequence? In an arithmetic sequences, the difference between any two consecutive terms is constant. For example, like this, like the number of the plus is constant, which is +3. All of the difference between these numbers are same. So for the formula to find nth term is Tn equals A plus n minus 1 d, where Tn is the nth term of the sequence. A is the first term of the sequence. D is the common difference between consecutive terms. N is the position of the term in the sequence. So to find the sum of the first n term, this is the formula. Sn equals n divided by 2 bracket 2a plus in bracket n minus 1 d, or Sn equal n divided by 2 in bracket a plus 1, where Tn and T equals to nth term, Sn equals to sum of the first n term, A equals to first term, n equals to number of terms, d equals to common difference equals Tn minus Tn minus 1, and L equals to last term. So for the geometric sequence is each term is obtained by multiplying the preceding term by a constant factor. So this is the example. It multiply with a constant number, which is multiplied by 2. So the formula for geometric sequences is Gn equals to A multiplied Rn minus Y, where Gn is the nth term of the sequence, A is the first term of the sequence, R is the common ratio between consecutive terms, N is the position of the term in the sequence. So the formula for sum of first n terms is Sn equals to A R n minus 1 divided by R minus 1 if the R is more than 1, and the other one if the R is less than 1. So the formula will be Sn equal A 1 minus Rn divide by 1 minus R, where Gn equals to nth term, Sn equals to sum of first n term, A equals to first term, N equals to number of terms, R equals to common ratio equals to N to Tn divided by T minus 1. So that's all for the intro. Now let's move on to the exercises.
Now I'll be presenting about arithmetic sequence. The first question: find the 14th term in the 2, 5, 8, 11, 14 sequence. So to start off, you need to identify the A first. So the A is equal to 2 because there is A1, A2, A3, A4, and A5. It's just that the A1 is invincible. So we need to start off with the first number, and then to find the n term is 40 because it's already stated in the question. And furthermore, we need to find the difference. So the difference, it's pretty simple. You need to minus the second term and then the first term. So 5 minus 2 is equal to 3. The difference is 3. And to move on, we need to use the formula. So the formula for the arithmetic sequence is En equals to A plus N minus 1 and D. This is the arithmetic sequence. Is an important formula. You need to use it for this topic because you're gonna help a lot. So as you can see here, we already find the N, the A, and then the D. So you can put in the number. A is I uppercase the letter. So the N is 40. A 40, and then the A is 2 plus N is 40 minus 1, and then the D is 3. 3. So 2 plus 3 times 40 is 122 minus 3. 2 plus 17 and 2 plus 117 is 119. So the answer is 119. This is how you find the arithmetic sequence. It's pretty simple. That's all for this subtopic. So the next type of question is sum of arithmetic sequence. Question 2. Find the sum of 7 terms of an arithmetic sequence whose first and last terms are 10 respectively. So to start off, you need to highlight the key points of this question, the important ones mostly. So the sum is the main clue. The 7 terms and the first and last terms are 10 and 40 respectively. So you can already know the sum. We need to use the sum formula. Sum formula is this one. That's n over 2 plus e1 plus en. I put a star because it's an important formula. So after you already identify all of the important key points, you can already start writing down. So E1 is 10, E7 is 40. So okay, 7. The reason is E7 plus 7 is the total of the total number of the sum of the arithmetic sequence. So and then you need to find the nth term. The nth term is the 7th term. So we can put 7th term, and then you can start putting all of these 3 digits into the formula. Sn 7/2 bracket 10 plus 40. Here I'm gonna use my calculator. Plus 50. 3.5 times 50 is equal to Sn equals to 175. So the final answer is 175. You can put your answer like this. The sum of an arithmetic is 175, and that's all you need to know on how to solve the question of a sum of arithmetic sequence. So thank you for watching, and that's all today for my presentation. Thank you.
Wafi has already talked about the arithmetic progression. I will be doing the geometric progression. So first, how do we differentiate geometric and arithmetic? So here we see a sequence like 1, 2, 4, 8, 16, right? And as for arithmetic, term minus the previous term, 16 minus 8, that would be 8. 8 minus 8 is not 4. So we know that this is not an arithmetic progression, but this is a geometric progression because 16 divided by 8 is 2, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. So we know that this one we need to multiply by 2 for each term. So this common ratio is 2. And these are the two formulas that we'll be using. This one is to find the term. Tn equals a times r power of n minus 1. Tn stands for the nth term. A is always the first term. In this case, it's 1. R is the common ratio, which is like 2. power of n minus 1, which is the position of the term in the sequence, minus 1. And this one is the sum of first terms formula for geometric progression. Sn stands for the sum of the first n term equals to a bracket r power of n minus 1 over r minus 1. This formula is only for if the ratio is more than 1. And r stands for the common ratio, which is the term over term minus 1. So here for the first application question, I have a question here. A rabbit population doubles every year. If there are 100 rabbits initially, how many rabbits will there be in 3 years? So the common ratio, we know that it says here, doubles every year, doubles. So it will be 2. And we want to find it in 3 years' time. So we'll be using this term formula. Term is the third term equals to A. A is the first term, which is 100, and then times with the ratio, which is 2. N is how many we're looking for, like how many years, so it's 3 years. So it's 3 minus 1. So term number 3 equals to 100 times with 2 power of 2, and that will become 100 times 4. So in 3 years' time, there will be 400 rabbits. 400 rabbits in 3 years. That's how we use this formula for this application question. Now for the second application, we're going to use the sum of the first n terms formula. The question is, now find the sum of rabbit in the first 10 years. So if we were to count manually, it would be really difficult. That's why we're going to use this formula. So we know here that same as just now. So the common ratio is r equals to 2, because doubles every year. A is 100, as is the first term. And now we want to find it in 10 years, not 3, yeah? So the n is 10. So now we're going to plug in the formula, which is Sn equals to A Rn minus 1 over R minus 1. Sum would be S10, because we're going to go for 10 years, equals to A is 100, bracket with ratio is 2 power of 10 minus 1 over 2 minus 1. So it will become S10 equals to 100. 2 power of 10 is 1024 minus 1 over with 2 minus 1 is 1. And that will become 100 multiplied with 1023, and final answer would be 102300. So we know now that the sum of the rabbit in the first 10 years using the sum of n first term formula would be 102300 rabbits. And that is how we apply the two formulas for geometric progression. Thank you.
For the conclusion of this topic, which is arithmetic and geometric sequences, so what we get from this topic is understanding the difference between arithmetic and geometric sequences. Identifying arithmetic sequences based on a common difference and geometric sequences based on a common ratio. And finding the nth term in an arithmetic or geometric sequence using the appropriate formulas. calculating the sum of the first n terms in an arithmetic or geometric sequences, and also solving problems involving finding specific terms in a sequences, determining the number of terms, and calculating the sum of terms. Lastly, developing problem-solving skills related to sequences and series in business mathematics. So, to sum up, this topic of arithmetic and geometric sequences can be able to analyze and work with various types of sequences, can apply the formulas effectively, and lastly, solve real-world problems that involve arithmetic and geometric sequences, including finance, statistics, and computer science. So that's all from us. Thank you.